So now let's continue. Historical background, Part 1, Newton, Leibniz, and Bernoulli. Without knowing something about differential equations and methods of solving them, it is difficult to appreciate the history of this important branch of mathematics. Further, the development of differential equations is in intimately interwoven with the general development of mathematics and cannot be separated from it. Nevertheless, to provide some historical perspective, we indicate here some of the major trends in the history of the subject and identify the most prominent early contributors. The rest of the historical background in this section focuses on the earliest contributors from the 17th century. The story continues at the end of section 1.2 with an overview of the contributions of older and other 18th century and early 19th century mathematicians. More recent advances, including the use of computers and other technologies, are summarized at the end of section 1.3. Additional historical information is contained in footnotes scattered throughout the book and in the references listed at the end of the chapter. The subject of differential equations originated in the study of calculus by Isaac Newton, 1643 to 1727, and Gottfried Wilhelm Leibniz, 1646 to 1716. In the 17th century, Newton grew up in the English countryside, was educated at Trinity College, Cambridge, and became Lucasian Professor of Mathematics there in 1669. His epochal discoveries of calculus and of the fundamental laws of mechanics date to 1665. They were circulated privately among his friends, but Newton was extremely sensitive to criticism and did not begin to publish his results until 1687. With the appearance of his most famous book, Philosophiae Naturalis Principia Mathematica, although Newton did relatively little work in differential equations as such, his development of the calculus and elucidation of the basic principles of mechanics provided a basis for their applications in the 18th century, most notably by Euler. Newton identified three forms of first-order differential equations: dy over dx equal to f of x, dy over dx equal to fy, and dy over dx equal to f of x and y. For the latter equation, he developed a method of solution using infinite series when f of x and y is a polynomial in x and y. Newton's active research in mathematics ended in the early 1690s, except for the solution of occasional challenge problems and the revision and publication of results obtained much earlier. He was appointed Warden of the British Mint in 1696 and resigned his professorship a few years later. He was knighted in 1705 and upon his death in 1727 became the first scientist buried in Westminster Abbey. Leibniz was born in Leipzig, Germany, and completed his doctorate in philosophy at the age of 20 at the University of Altdorf. Throughout his life he engaged in scholarly work in several different fields. He was mainly self-taught in mathematics, since his interest in this subject developed when he was in his 20s. Leibniz arrived at the fundamental results of calculus independently, although a little later than Newton, but was the first to publish them. In 1684, Leibniz was very conscious of the power of good mathematical notation and was responsible for the notation dy over dx for the derivative and for the integral sign. He worked on and did much to develop methods of solving differential equations and to extend the range of their applications. Jacob became professor of mathematics at Basel in 1687, and John was appointed to the same position upon his brother's death in 1705. Both men were quarrelsome, jealous, and frequently embroiled in disputes, especially with each other. Nevertheless, both also made significant contributions to several areas of mathematics. With the aid of calculus, they solved a number of problems in mechanics by formulating them as differential equations. For example, Jacob Bernoulli solved the differential equation y prime equal to this term in 1690, and in the same paper was used the term integral in the modern sense. In 1694, John Bernoulli was able to solve the equation dy over dx equal to y over ax. One problem that both brothers solved and that led to much friction between them was the Blanchester-Chrome problem. The Blanchester-Chrome problem was also solved by Leibniz, Newton, and Marquis de Hotto. It is said, perhaps apocryphally, that Newton learned of the problem late in the afternoon of a tyrant day at the Mint and solved it that evening after dinner. He published the solution anonymously. Upon seeing it, John Bernoulli exclaimed, "Aha, I know the lion by his paw." Daniel Bernoulli, 1700 to 1782, son of John, migrated to St. Petersburg, Russia, as a young man to join the newly established St. Petersburg Academy, but returned to Basel in 1733 as professor of botany and later of physics. His interests were primarily in partial differential equations and their applications. For instance, it is his name that is associated with the Bernoulli equation in fluid mechanics. He was also the first to encounter the functions that a century later became known as Bessel functions.